everyone, in this video I'll show you how to solve and refine a crystal structure using OLX software. So this is the interface of OLX and I have already opened one file which is hct.ins. In this structure the parameters are given over here, ABC and alpha beta gamma. This is the space group P21 and this is the chemical formula. Now HCT has a structure this, so we'll just according to this structure we'll solve the given data. So we'll just solve using the ShellX program and with the direct method. So after solving you will just see these balls which represents the electron density, and in the structure we have seen there is a benzene ring, so we'll just simply assign these uh, electron density as carbon. There's a toolbox over here, we'll assign carbon to these, and then there was another 6-member ring in which sulfur was adjacent to the nitrogen atom and the nitrogen was opposite to the sulfur, so we'll just assign these. Also the software might get confused between sulfur and chlorine, so we'll just by guessing we'll just put this as sulfur, and opposite to sulfur there was one nitrogen and adjacent to sulfur there was also one nitrogen. We'll just assign this as carbon. Now we'll just scroll down the electron density and there is 2 oxygen left on the sulfur, so we'll assign these as oxygen, and now we'll just simply refine this. After refining you'll see there's a shift between the there is a change of the structure, and you can see there's R value which is 21.8, so it should be between 0 to 5. Now we'll try to decrease this R factor, and this should be the chlorine because the sulfur and chlorine are very much similar in electron density, and there two sulfur there are 2 oxygen attached, so this will be the 2 oxygen. Okay, so now with sulfur there was one nitrogen attached, so we'll assign this as nitrogen. So to refine the thermal energy of this structure we'll just click on the ellipsoid icon. This will make the structure include the thermal vibration of the atom in crystal structure. Now we'll refine it. As you can see there is 4, R value is equals to 4, and now we'll just simply add hydrogen to this structure. Hydrogen is added, but there is ammonium ion here, so we'll just simply remove one hydrogen from this side. And now we'll refine it. And you can see that the R factor has been decreased to 3.8. So by simply adding the hydrogen the R factor has been reduced to 3.7. Now we'll just download the report and it will generate a report of all the lattice points in this. So this is the space group alpha beta gamma ABC, and the density is also shown here, and these are the various fractional coordinates of the atom. After generating the report we'll open the Vesta software, and we'll open this report which is a zip file, and you can see over here that it generated one structure. It is of HCT and we can see the structure here. Now we'll simply get the PXRD data from this by going to the utilities and powder diffraction pattern, and then we'll just have the PXRD pattern of this structure, which is this. Is RML, the chemical formula is written over here. This is the space group alpha beta gamma written over here. The RML has a salt which is known as Riluzole salt. The structure of Riluzole salt is this. It is with malonic acid, so we'll just simply solve this again using the program ShellX and with the direct method. This is the structure we got. Now again we can see the 6 rings which we can assign carbon to these. Now with this, one oxygen is attached, so we'll assign this as oxygen, and the oxygen is attached to the carbon. Then this carbon is attached to the fluorine as per the structure, so we'll just simply assign these values. Now in the structure, the sulfur is attached to carbon, then it is attached to the nitrogen, so it is attached to the carbon, then it is attached to the nitrogen, and this carbon is attached to the nitrogen. So we'll just, this is the structure we got by our final by our initial guess, so we'll just define this structure. Now we can see this is the structure we got after refining it. So we'll just if there is a malonic acid, so it will be similar to this, we are not getting it, but we can just simply by guess we can assign this carbon with 2 oxygen. Then again we'll refine it to get the better structure. Now this is the structure. We'll just this, if this is a malonic acid, so this will be carbon and this will be oxygen, so we'll refine it again. As you can see, the R factor is decreasing, like it is 34, then it is 22 now, so we'll just assign 1 oxygen to this. Again we'll refine it, and then we'll just click on the ellipsoid ion to refine the thermal energies. And now as you can see, the R value is 5, that is, it is a bit closer to the final structure. Now we'll add hydrogen to this. By adding hydrogen, there is interaction shown, the ionic interaction has been shown, electrostatic. Now we'll refine it again. So this is the structure, final structure. As you can see, the R value is between 0 to 5, so we'll just simply download the report, and by downloading the report, we'll open it into Vesta software. This is the report generated, which say the crystal system is monoclinic, ABC are written over here, alpha beta gamma are there, volume, density, and these are the fractional coordinates for the system. This is the zip file generated. Now we'll open this zip file into the Vesta software to get the data. So these were the initial file, and this is the final zip file. So we'll open this zip file, and you can see this is the structure, the crystal structure. And now we'll just go to into the utilities, and then click on the powder diffraction pattern, and then just calculate the PXRD. This is the PXRD of this RML structure. The structure, which has chemical formula this, basically this is Riluzole with phosphoric acid. We have already solved this, and you can see the electron density. There is one benzene ring over here, so we'll just simply assign this as carbon. Now the carbon benzene ring was attached to 5-member ring which has sulfur, nitrogen, and along with 1 carbon. Now there would be 2 nitrogen. Now in this structure you can see that the benzene ring is attached to the oxygen also, so it would be oxygen, and this oxygen attached to the carbon, which is further attached to 3 fluorine atoms. And as this structure is also with phosphoric acid, so we'll assign this atom as phosphorus. Now we will refine the structure, and after refining we can see there are four atoms which we can assign as oxygen. Yes. Now we can again refine it. The R value is 36. Now it should decrease to a bit. Now it is 10. Then we will just click on this icon to refine the thermal energies. Now we can add hydrogen in this structure. As you can see, the interactions are being shown over here with the oxygen with the hydrogen of nitrogen. Now we can simply refine it. The R value should decrease to 3.3. So we will download the report, and after downloading the report we'll open this in Vesta. This is the report which shows all the data, fractional coordinates. So we'll open this in Vesta. So this is the zip file which we'll open. This will generate a crystal structure. As you can see, this Vesta software, and then we'll go to utilities and calculate the PXRD pattern. So this is the PXRD pattern of this salt. Thank you so much.